And next up, we're going to welcome someone who goes overboard with aligning his colors to the theme of the conference, Adrian Brink, co-founder of Anuma. Adrian, thank you. He's going to talk about intent-centric architectures for fully decentralized apps.
Cool, this works. Does it? Yes. Hello. Thank you all for coming. I'm Adrian. I'm one of the co-founders of Anuma. And today I'm here to very briefly talk to you about unified architectures for full stack decentralized applications, or what we are trying to build with the Anuma architecture. So let me start off by sort of a brief historic recap on sort of where we started and how we got to where we are today, which is really that, in my mind, the first evolution of protocols really was, it started with Bitcoin, which was the first generation, and it gave us scriptable settlement. So when you think of the first generations, it's not only Bitcoin, it's also Litecoin, Monero, Zcash. They all kind of fall into this category, and they all just gave us scriptable settlement. It was a limited form of programmability that developers had access to. And really, this started with Bitcoin. It allowed us to do cool things like build cryptocurrencies. But even in the early days, it became apparent that one of the very nice things is that people want to build things on top of it. So we started having things like colored coins, like Namecoin. I don't know, maybe anyone in the audience remember the global Bitcoin stock exchange? Like, we tried to have the first kind of, I don't want to call it a DEX, but so the first attempt at building trading systems on top of Bitcoin. Does actually anyone remember the global Bitcoin stock exchange or used it in the audience? OK, no. This was a very early unregistered securities market run out of the States that allowed you to trade real-world stock. It was interesting. Like, the first couple of colored coins were traded there. But there were obvious problems with scriptable settlement. And a lot of the applications that were being built at the time were incredibly clunky to use. For example, actually, here to use Namecoin, you needed to run a forked client of the Bitcoin core client in order to run Namecoin, right? So there were lots of drawbacks to using just scriptable settlement. And as a result, we got the second generation of protocols, really, which was programmable settlement. And this all started with Ethereum. And interesting enough, Vitalik actually talks about this in the white paper, that one of the reasons for Ethereum was the limitations of scriptable settlement. And all of a sudden, we managed to move away from colored coins, and we went to ERC20s. We could move away from Namecoin and went to the ENS. But the nice thing is, there were also a bunch of applications that we didn't think about when Ethereum was designed, right? Like, there were a bunch of new things like soul-bound tokens, NFTs, DAOs. No one really thought about NFTs back when Ethereum was being originally developed, because everyone was still in the model of, like, what's buildable on Bitcoin and how can you make this better? So in the same way that you could build colored coins on Bitcoin, you can build modern applications, modern ERC20s on Ethereum right now. But again, there are trade-offs, right? We have a lot of cool things like modern DEXs and AMMs and NFT marketplaces, but they are also clunky in a lot of ways. Generally speaking, they're application specific, as in you don't have composability between the different applications except for at the settlement layer. And they generally require at least one Web 2 or centralized component. And actually, a good example here was the previous talk in Fura, right? So we're always in this model, how do we fully decentralize modern dApps? So we have a ton of cool things, but all of them, if you think about it, like OpenSea, right? OpenSea just a settlement on Ethereum. All of the counterparty discovery as well as solving component is fully centralized. 0x is the same problem. All the rollups have exactly the same problem. It's like optimism, right? You interact with a centralized Web 2 server that does the solving. And I think, especially in the world of increased regulatory scrutiny, having these very centralized failure points is not going to be a long-term sustainable model, because they're the most obvious places for people to attack. I also don't want to forget that there were a bunch of other innovations since 2014 or 2015 with Ethereum, but in my mind, really, it's the programmable settlement ++ model, because Albeit we had advances in stable resistance, right? We moved away from proof of work and moved towards proof of stake. We had advances in scaling. We now have rollups. We have advances in privacy with Zcash and Zcash-like things. And we definitely had a lot of advances in consensus, like Tenement, Avalanche, and eventually ETH2 single slot finality. All of these systems are still programmable settlement fundamentally. Like, I think everyone sort of since 2015 has claimed that a bunch of the sort of newer blockchains are fundamentally different, but really it's just an imperatively executed VM. It's a slightly different color, but whether this is Ethereum or Avalanche really doesn't change the fundamental underlying model that application developers have access to. Sorry. Nope. There. OK, so one of the big insights is that when you look at modern dApps, that settlement is not sufficient. Settlement happens when parties already know who they are, what they want to settle, and with whom they want to settle. But practically speaking, a lot of applications actually need infrastructure for counterparty discovery. They need help discovering each other parties with whom to trade. For example, this is the case of what the centralized OpenSea server does at the moment, right? Like, I want to trade some CryptoKitty against some ETH. I send this to a centralized server. That centralized server receives a bunch of these messages and then figures out which ones are combinable and settleable on chain. And in some cases, you also need infrastructure to help counterparties agree on exactly what they want to be settling. We have lots of examples here. I mean, there are marketplaces where you have buyers and sellers. Quadratic public goods funding is the same thing, where you need to sort of have counterparty discovery for project donors and funders. There are DAOs where you want to not do the calculation of the votes on chain, but rather you want to be able to aggregate all these votes first. And then you have rollups. Right, so what are contemporary approaches to counterparty discovery? Well, in my mind, there are roughly 3 approaches that we're currently using. One, you do on a blockchain. This is what Uniswap does. This is what every AMM does. And I have to say, Uniswap is sort of the single best case that you can do if you want to do counterparty discovery on chain. It is the single most gas-efficient way to do counterparty discovery on chain. You could theoretically also do an on-chain order book, but that's incredibly expensive, and as a result, no one does this. But when you really think about this, why are we doing this? Using a globally ordered settlement layer is incredibly expensive, and it's kind of silly because you don't really need a global total order over all these different messages that go into an AMM, for example. So doing counterparty discovery on a blockchain, yes, you can optimize for this, but it severely limits the kind of applications that you can build in a fully decentralized manner. The second option is you do sort of the single operator database. You do the OpenSea model. You run one single Web2 server that acts as the shelling point that everyone sends their intents to, that then figures out who should coordinate with each other. 0x does this. The Flashbot relays do this. Every rollup sequencer or rollup prover does this too. Obviously here, the big downside is that these are now trusted parties. I mean, we've gotten pretty good at this, where at least they probably can't steal your money, but at the very least, in most cases right now, they can completely censor you and refuse, and not actually only censor you to enter the system and transact in it, but in most cases, they can certainly also prevent you from leaving the system, so they can indefinitely censor you, which I would say is roughly the same as being able to steal your money. So that's the second approach, single operator database. And the third approach right now is sort of app-specific sovereign chains. A bunch of people like DYDX are trying this. There are other trade-offs here, which is you have tons of dev work in order to make this work, and you lose all composability between the different applications, because now a user can't just interact with many different applications on the same chain, but rather they have to go to a unique chain for every single application they want. So in the last 10 minutes, I'd quickly like to talk you through sort of what, in my mind, is the third generation of protocols, which is a unified architecture for full-stack decentralized applications that not only takes into account how we design programmable settlement systems, but also takes into account how we design decentralized counterparty discovery and distributed solving. So ANOMA in a nutshell. And here it's important to remember, ANOMA is an architecture. You can deploy ANOMA in many different ways, and hopefully people do. You can deploy ANOMA as a sovereign L1. You can deploy ANOMA as a City of Berlin settlement system to facilitate financial transactions in Berlin. You can deploy ANOMA as an L1.5 to decentralize a specific dApp on Ethereum, or you can deploy ANOMA as an L2, where all the settlement fundamentally happens on Ethereum. So ANOMA is an intent-centric, privacy-preserving protocol for decentralized counterparty discovery, distributed solving, and atomic multi-chain settlement. So the two key design principles here are intent-centricity and homogeneous architecture and heterogeneous security. And I'll go through both of them in order. So intent-centricity, what does this mean actually? In the current model, people don't have intents. Like in every existing blockchain, the fundamental unit is a transaction. But a transaction is a finalized state transition that we can settle on some underlying system, right? It's like, I want to send money from A to B. But it's not a transaction that I want to sell a CryptoKitty for some ETH. And this is generally what users have. Users have partial transactions or partial state transitions, and we're calling them intents, because users fundamentally express what they want, and they don't have access to all the existing state because, like, you have this if you're in a supermarket, because the supermarket acts as your counterparty discovery point. So users express what they want, not how to get it. And intents are binding programmatic commitments to state preferences. One of the other nice things is that this aligns much closer with how ordinary people think about signing messages, right? Because in the current model, when I, as a user, sign a transaction, I don't authorize a specific state change. I authorize some execution trace that involves a bunch of opcodes, and these opcodes can do arbitrary things. This means that as a user, I really honestly should be auditing every single opcode that I sign over, because they may do arbitrary things. So like, I'm authorizing not a specific thing that someone else has some money or that I'm trading some asset. I'm authorizing very specific opcodes to be executed in the context of global Ethereum. Yeah, so, and really, like, my parents think about this in the sense that they are willing to spend some money or move some funds around. They aren't thinking about, am I authorizing the right server calls behind the Visa network, right? Once you have intents, you can build a P2P intent gossip network. And here the cool thing is you can have 100 million of these intents floating around the same point, in the same network. No one needs to have a globally consistent view of this. Not all of these intents are going to end up settled on some underlying settlement layer. And as an intent gossip node, I can decide which intents I care about. Maybe I only care about the Bitcoin to ETH intents and some NFT trading intents, but not about all the other things. And in the sort of global intent network, you can do this. Then you have solvers, where solvers find compatible intents, and you have the soup of intents lying around, and you go, and solvers can look at this and go, which ones of these are combinable? Which ones actually satisfy each other, and which ones are, as a result, settleable on some underlying settlement system? Here, the really cool thing is that this also means that intents are now composable. So the OpenSea intents and the 0x intents can be composed into a single transaction. I am not tied into a fundamental dApp where I can only trade on OpenSea, but the OpenSea trades can share the liquidity together with the 0x trades. Yes, this kind of intent-centric design is necessary to enable decentralized counterparty discovery. And since intents only state what kind of future state transition you're willing to accept, it leads to this very declarative paradigm for decentralized applications. This also means that users don't have to care what happens in the middle. Users author and submit intents that say what future state they're willing to accept, and then magic happens, right? This means, like, I may want to trade some let's say 1 Bitcoin for 100 ETH. This could mean that there is one other counterparty that fills this trade, or that there is 100. And as a user, I never have to care about this, exactly how many counterparties there are to me, because the system can just figure out what's sort of the best settlement route for me. And in the end, users only need to check whether their intent was correctly settled or not. So since I only have 6.5 minutes, I won't go through the entire diagram. But this is sort of a high-level overview of what ANOMA looks like and what this kind of architecture looks like. On the left here, you have intents, and you have users, and users author intents. These could be transparent, shielded, or private. The clients then sign them, and this may also involve the generation of a bunch of zero-knowledge proofs if you want to associate privacy guarantees with this. They then get submitted to the intent gossip network, and intent gossip nodes gossip the intents around that they care about. Solvers look at this pool of intents and go, which ones are combinable? And this is not a permissioned role. Anyone can run a solver, and anyone can specialize on a specific subset of intents that they care about. Once solvers have found effectively solutions that maybe combine 15 different intents together, they submit this as a transaction in consensus. Here the question becomes, why would anyone run a solver if someone else can just front-run them? And the answer really is that front-running is relatively straightforward to solve if you're willing to incorporate, like, re-architect your base layer, which means that, for example, like in Anoma, we're using something called Fairview, which just means that there's a distributed key generation protocol that has a single shared public key. Transactions are encrypted against this shared public key. Then encrypted byte strings are put into blocks. Validators finalize those blocks. And then on block n+1, those transactions are decrypted and then executed. At that point, they aren't front-runnable anymore. You can't front-run, back-run, or sandwich them anymore. You also can't submit them with a slightly higher gas fee because by the time they're revealed, they will, you cannot change the ordering anymore in which they appear. And yeah, and then once you now have a block with a finalized block with a bunch of decrypted transactions, it comes into this execution and verification phase where there's a unified execution environment which can handle transparent, shielded, as well as private state. OK, the last bit I want to talk about is homogeneous architectures and heterogeneous security models. Protocols can very easily be benevolent monopolies because everyone pretty much wins by agreeing on the same protocols. Like, we all win from agreeing on the same cellular backbone or the same protocol for TCP/IP. Because the counterfactual losses are marginal. And like, this is a very nice design criteria in the real world because it allows things like, I can take my phone that I bought in Switzerland and use it on the cellular backbone in the States or in South America. And I don't have to, if we didn't agree on the same protocols, I'd have to buy new phones for every single sort of security model I went into, effectively. But crucially, security domains shouldn't be monopolies. Because security domains can steal your money, they are non-local, they can extract rent, and it's very hard to abstract the kind of security guarantees that actually security domains give you. So really, what you want to do is you want to be able to separate the protocols and architectures from the underlying security model, and ideally deploy the same kind of architectures in many different security models, because different people have different preferences for what is their preferred security model, right? Like, I think my parents don't really want to trust global ETH because they don't understand it, but they may very well trust sort of their local village of 500 people to secure their assets. And the important thing is we shouldn't force people into specific security models. We should allow people to pick the security models that they're comfortable with. So this kind of thing means that you can deploy Anoma in many different ways. You can deploy Anoma as a sovereign chain, as a sovereign global L1. You can deploy it as a community-operated chain. Maybe the city of Berlin can run this kind of architecture to facilitate financial transactions within Berlin. You can deploy it as an L1.5 to decentralize a specific L2 or a specific dApp construction. Or you can deploy this as an L2 where all the settlement still happens on Ethereum. Or some other underlying settlement system, by the way. Like, we are not that opinionated about where Anoma gets deployed. Right, what do these deployment patterns look like? So the first one is you only use the intent gossip network and you sequence and settle elsewhere. The second one is you also use Anoma to decentralize your solvers or roll-up sequencers or provers. Or the L1.5 case is you use this to decentralize specifically 0x or CowSwap. Or the third model is you deploy this as a local instance. Okay, 2 minutes, all right. So what do dApps look like on Anoma? Well, dApps have roughly 3 components. You have intent formats, which just describe what kind of, like, what's the structure of your intent, because an intent can just be arbitrary WASM that's executed at runtime. You have solver algorithms, at least basic ones, that can figure out of these 15 intents which ones are settleable and combinable. And you have validity predicates that enforce settlement invariants, like if I'm transacting in Bitcoin, I cannot be creating new Bitcoins out of thin air. Like, I need to be making a zero-state change here. This kind of vertically integrated architecture means that you get very nice end-to-end security, liveness, and privacy guarantees. And importantly, you don't get vendor lock-in, as in your applications are portable across security domains. As in, if I'm flying from Berlin to New York, my application can now work in a different security domain. If I change my mind that I maybe don't trust this validator set anymore, I don't have to change all the applications I'm using. I can just change my underlying security model. Right, so what can you build with Anoma? And similar to sort of back in the day when we thought about what could we be building on Ethereum, when Ethereum was being developed after sort of we discovered the limitations of scriptable settlement, these are sort of examples of existing dApps, but with full stack decentralization. I spoke a bunch about decentralized exchanges, as well as whether for fungible tokens or non-fungible tokens and AMMs. Rollups as well, that you can definitely use ANOMA to decentralize a specific rollup. You can also build cool things like public goods funding in a fully decentralized way, where instead of trusting or semi-trusting a semi-decentralized, semi-centralized multi-sig run by the Gitcoin team, donors can rather have intents, and once you have reached enough intents, you can settle them on-chain to fund the right projects. But I expect that there's also a category of things that we aren't thinking about yet, but that eventually we'll be able to build with ANOMA as we explore this kind of generalized intent-centric architecture more and more. So these are some examples that I keep thinking about. Private DAOs is one example. I'm pretty excited about private auctions because with this kind of programmable threshold decryption system, you can actually build decentralized second price auctions where all the bits are kept private. 2 minutes, great. Or private games. The other thing I'm also very excited about is multi-party, multivariate private bartering. It is the idea that you can have sort of user-defined marketplaces because there's not a single order book anymore, but rather every intent creates its own order book, and you can settle across 15 different order books at the same time, or n order books, really. Yeah, so thank you very much. This is sort of, ANOMA is not only built by me, Awa and Chris, it's an entire team behind this. You can check out the team. And yeah, thank you very much. This is ANOMA, a unified architecture for full stack decentralization.
Thanks, Adrian. Thank you so much.
Do we have time for questions?
Exactly. We have a couple of minutes for questions. If you have one, just raise your hand and we'll bring a mic to you.
Hi, could you speak more to the intent gossip network? Is it fast and scalable enough for the purpose?
Yes, so this is, importantly, intents aren't consensus critical. So you as an intent node, you can have a completely different view of what intents exist than a node next to you. As an intent node, you can also specify which intents you actually care about. So for example, maybe you only care about a specific pair for the intent, and so you don't have to process all the global intents. If you want to build a solver, there's probably an argument that you should be listening to as many intents as possible. So intent nodes are sort of very configurable in terms of performance needs that they have. Cool, thank you very much. Another question? Yeah, up there. Since you don't have to see the intents, as in you can sync any underlying chain even if you didn't see the intent, anyone that DOSes you can just ban you as a peer. Similar to like how you solve existing DOS, this is the same problem.
All right, thanks.
It's time for one last question over there.
How do fees work exactly?
Right, maybe I actually didn't go through this in enough depth here. Intents aren't specific, as in intents are just wasn't. So there could be standards around this where, so you're not sending around pairs, right? Like I use the example of BTC ETH a lot. But the intent doesn't actually know what a pair is or what a price is or what an asset is, so just code, which means that that code can just contain a user-defined fee field for the fee, and this gives you the nice property that maybe you have a very complicated intent that requires someone to drive to a remote location to pick up a physical item for you. At that point, in order to convince someone to do this for you, you may want to attach a $100 fee with this. If you're just willing to trade in a super liquid, or if you just want to trade in a super liquid market like BTC ETH, you may not have to pay a fee at all. It's completely user-defined. Cool. Thank you very much.
Thanks so much, Adrian.